Hey guys, Jake here coming at you with another math lesson today. Today we're going to continue our discussion of the foundations of differentiation from my new book, The Elite Guide to AP Calculus AB. Go get yourself a copy. It's available on Amazon. You can scan the QR code up in the corner of your screen or go check the link down in the description or the pinned comment below. But today we're going to be continuing about differentiation and we're going to be talking about product rule. So we're going to go through this example here. We're going to differentiate g of x equals sine of x times cosine x. And as I kind of alluded to, we're going to need to use the product rule to do it. So first of all, I just want to point out how you know you need to use the product rule. So in this case, we have this function that we're going to be taking the derivative of, and you can clearly see that this function is just the product. It's just two kind of smaller, simpler, more elementary functions being multiplied together, right? So we very clearly have sine of x times cosine of x, right? We have these two kind of smaller components being multiplied together. That indicates that we need to use the product rule. The product rule would be used whenever you need to find the derivative of some function that is just two smaller functions multiplied together. Now, in order to use the product rule, you're pretty much just going to want to use the formula. So the product rule formula basically just says that if we want to find the derivative with respect to x of product of two functions, let's just call it f of x times g of x, the derivative of this product of two simpler functions would just be the derivative of the first, f prime of x, times the original of the second, plus the original of the first times the derivative of the second. Now, before kind of jumping into this problem and showing you how to use this formula, I want to just briefly talk about how to remember this formula. So the really nice thing about it is notice that all we have within this formula is multiplication and addition, right? We have these things being multiplied and added, right? There's no subtraction. There's no kind of additional negative signs put in. There's no dividing. The reason why that's significant, or the reason why that's kind of nice, is multiplication doesn't care about order, right? A times B is the same as B times A. Or in other words, f prime times g is the same as g times f prime. So the order of, which of these two things you're multiplying with each other, the order you write it doesn't matter. Addition is the same way, right? A plus B is the same as B plus A. Or in other words, the product of these two functions plus the product of these two functions, it would be the same if you flipped it. So the order of kind of those bigger pieces of our formula also doesn't matter. The only part that matters about this formula in terms of making sure that you get the correct components lining up and the order correct is you need to multiply the derivative of one of your functions by the original of the other function, and vice versa over here, right? The derivative of g times the original of f. So the way you can remember this formula is the first thing you want to do, and maybe it'd be better to kind of show you this with our example over here. So let's go back over to our example and I'll kind of wrap around what I'm saying to this. The first thing you want to do, and actually I'm going to rename this function. I'm going to call it h of x instead of g, just so we can kind of use f and g like our formula and not have that be confusing. We're still going to find the derivative of sine x times cosine x. The first thing you want to do when you're applying this formula is figure out which function you want to call f and which function you want to call g. Like I pointed out, since the order of these components doesn't really matter, it doesn't really matter which you call f and which you call g, as long as you're correctly identifying kind of the more, broad definition of the product of these two functions. In this case, there's really only one option. There's really not much that we can do to mess this up. Sometimes if you're getting more complicated functions that you're taking the derivative of, it might be a little less clear, but you want to make sure to kind of think of it in reverse order of operations. What would be the last operation that you would be doing if you were to plug in some x value and evaluate this function? First, if you were to do that, you would replace your x's with some number, You would then do what's inside the parentheses. So you'd figure out what sine of that number is, figure out what cosine of that number is. And then the last thing you would do is multiply those two results together, right? Because that's the last thing you would do, product rule would be the first thing we would want to use to find the derivative of this function. So it's kind of a reverse order of operations of plugging something in. The last step in evaluating this, if we plug some x value in, would be to do this number times this number. So that is how we can break this up for the product rule, is we would get this sine of x component as one of our functions, we'll just call it f, and this cosine of x component as our other function, g. So we're going to say f is sine of x, g is cosine of x. Then, once you have figured out what you're going to call f, what you're going to call g, you want to figure out what is f prime and what is g prime. So then you'll figure out f, or f prime, I'm sorry. F prime is just going to be the derivative of whatever you called f. So in this case, if f is sine of x, f prime is just the derivative of sine of x, which is cosine of x. And then you want to figure out g prime as well. You want to figure out the derivative of this other component. If g is cosine of x, the derivative of g would be negative sine of x. Okay, so once you've identified what is f, what is g, what is f prime, what is g prime, this is the one component, one piece of applying this formula you want to make sure you do in the correct way, the correct order. You need to make sure that the original of one is being multiplied by the derivative of the other. So f needs to be multiplied by g prime. And then you want to make sure that the original of the other one is being multiplied by the derivative of the other one. So then f prime is multiplied by g. So that's the important part. You want to make sure that g is being multiplied by f prime and that f is being multiplied by g prime. The way I like to think about it is I always like to identify and write out what is f, then what is g, and I'll put those to the left and to the right of each other, just like we have them here, f on the left, g on the right. Then beneath f, I write f prime. Beneath g, I write g prime. And then you can cross multiply them across each other. So you're making sure that you're doing a derivative times the other original, a derivative times the other original, right? That's the important part. As long as you make sure that is done correctly, the order that you write them in the next step doesn't really matter, right? So as long as we do sine of x times negative sine of x, and then we do cosine of x times cosine of x, that's the important part. Then we just need to add these together. And again, the order doesn't matter. So we could have written negative sine of x times sine of x. That's the same as what we have up here. Obviously, these are the same, so cosine of x times cosine x is the same even if you flip-flop them. But then we also could flip-flop the order of, writing sine of x times negative sine of x second, and we could have written cosine times cosine first, and it would be the same, right? So that's not important. The important part is that you do the original of one times the derivative of the other for both kind of products. Once you do that, then you just add them together. Take the sum of those two multiplying components. Then from there, it's just simplifying. So sine times negative sine would just give us negative sine squared of x. Cosine times cosine would give us cosine squared of x. And now in this case, what you could do if you really wanted to continue simplifying, you could actually switch the order of these two, because that would give you cosine squared of x minus sine squared of x. Which cosine squared of x minus sine squared of x, based on the double angle, one of the double angle formulas, is equivalent to cosine of 2x. So that's one way you could kind of simplify this down further. But really the important part is getting to this step by applying that product rule formula. So I hope you found this video helpful. If you did, be sure to hit that like button, subscribe to my channel. I'm going to continue going through lots more topics from the Elite Guide to AP Calculus AB in the coming months and weeks. So if you're taking the AP exam coming up in May, I think there's going to be a lot of value for you on my channel in the next few months. So be sure to hit that subscribe button. Thanks, and I'll see you next time.